Welcome to the video on converting fractions to decimals. At the end of this video, you should be able to say, I will be able to convert fractions to decimals and recognize that once converted, that fractions and decimals are equal. So in your notes, you're going to see here that you have a fraction. You have your top number and you have your bottom number. The top number is called your numerator. So I want you to go ahead and I want you to write numerator. Okay? That's called your numerator. All right? And your bottom number is called your denominator. All right, in order to convert a fraction to a decimal, we have to divide. So the bottom number, or the denominator, always goes on the outside of the division symbol, okay? And the numerator always goes on the inside. Now, to convert a fraction to a decimal, you would put this is what I just said, you would put the denominator on the outside of the division symbol and the numerator on the inside of the division. And this is always, whether the numerator is bigger or smaller than the denominator, it always, always, always goes this way. The denominator on the outside and the numerator on the inside. Because the numerator is how many parts we have, and then the denominator is what makes our whole. And we can relate that to what we just did with ratios, comparing a part to a whole. All right, so let's go ahead and look at our first example here. So what goes on the outside again? The denominator. And what number is our denominator? It's the 2. So go ahead and put the 2 on the outside and then the 1 on the inside. Now, can 2 go into 1? Think about that for a moment. If you said no, that's correct. So we're going to say it goes in 0 times. It cannot go into 1. So what we're going to do is we're going to need to add a decimal and some zeros. I usually like to add 3. We won't always use the 3, but the most you'll ever have to take it out is 3. So I always automatically add the decimal and then 3 zeros. So now let's take a look. Can 2 go into 10? Yes, it can. So the first thing we need to do is bring the decimal up. So I'm going to add the decimal. And 2 goes into 10 5 times. 2 times 5 is 10. We subtract and we're left with 0. So this problem we're done. So 1/2 equals 0.5. And you may already know that, and that's why we started with an easier one. So I want you to think about it. If you have $0.50, that's the same thing as 50 cents. Okay? So these two are equal. So this relates it to something that you're already familiar with. Let's look at another example. So we have 1/4. Again, you may already know this one, but just for the sake of practicing, let's go ahead and put the denominator on the outside, the numerator on the inside, with a decimal and 3 zeros. Okay, so the numerator cannot go into 1, so we put a 0. We bring up the decimal, and then we see how many times can 4 go into the 10. 4 goes into 10 2 times. 2 times 4 equals 8. So we subtract, and then we say 10 minus 8 is 2. And then we bring down our 0. And 4 goes into 20 5 times. 5 times 4 is 20. Again, we have no remainder, so our answer is 0.25. Again, we can look at 1/4 or 1/4 as 1/4, and that is the same thing as 0.25 or 25 cents. All right, let's look at our next one. The next one, the 3 goes on the outside, that's our denominator. The numerator goes on the inside with a decimal and 3 zeros. Now, how many times can 3 go into 1? It can't. So again, we put a 0, we bring up the decimal, Okay, and how many times can 3 go into 10? Well, it goes in 3 times. So 3 times 3 is 9. We subtract 10 minus 9 is 1. We bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. We subtract. 10 minus 9 is 1. Bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. We subtract. We get 1. Here you're going to notice a pattern. We're repeating the same number over and over and over. So we're going to use something called a repeating bar for fractions that repeat. All right, so we're going to use 0.3, and then we put a line over the 3. That means that the 3 goes on forever and ever and ever, and it's never going to stop. Another fraction that we're going to use quite often that we have the same situation is when we do 2/3, okay? So go ahead and make a note in your notebook that 2/3 is going to give you the same situation. Let's go ahead and take a look at what happens with that. Okay, this time you're going to notice that we have a number different than 1. So can 3 go into 2? No, because 2 is still smaller than 3. So we're going to go ahead and put a 0. We're going to bring up our decimal. Now can 3 go into 20? Yes. And how many times does 3 go into 20? Well, it goes in 6 times. 6 times 3 is 18. 20 minus 18 is 2. Bring down the 0. Okay, notice we're back where we started at the 20 again. 3 goes into 20. 6 times 18. Bring down the 2. All right, 3 goes into 20 6 times. So 2/3 is equal to 0.6 and repeating. That means the 6 is going to go on forever and ever and ever. All right, let's go ahead and do another one. So we're going to say 5, or the denominator on the outside, numerator goes on the inside. 5 goes into 1, 0 times. We bring up the decimal. 5 goes into 10, 2 times. 2 times 5 is 10. We subtract. 10 minus 10 is 0. So we are done. So the decimal for 1/5 is 0.2. Now we can do the same process with 2/5, 3/5, 4/5, but for today I'm just sticking with all the numerators of 1, but you are welcome to practice all of them if you'd like. All right, let's look at another one. Here we have 1/8. Okay, the denominator goes on the outside and the numerator goes on the inside with a decimal and 3 zeros. 8 goes into 1, 0 times. I bring up my decimal. 8 goes into 10, 1 time. 8 times 1 is 8. 10 minus 8 is 2. I bring down my 0. 8 goes into 20, 2 times. 2 times 8 is 16. Okay, 20 minus 16 is 4. I bring down my 0. 8 goes into 40, 5 times. 5 times 8 is 40. I subtract, and I have no remainder. So my answer for this terminates. That means it's done. It stops there. So it is 0.125. Now this is an exact answer, but if I ask you to round to the hundredths place, that means we have to look at the 5 and determine. If it's 5 and up, it goes up 1. If it's under 5, it stays as it is. So since this is a 5, our answer is 0.13 if I ask you to round it to the hundredths place. If I don't ask you to round it to the hundredths place, then you're done right there. If you need to, go ahead and pause the video here, or we're going to go ahead and go on to the other side of your page when the numerator's bigger. All right, let's go ahead and look at this one. Here, again, the denominator goes on the outside, the numerator goes on the inside with a decimal and 3 zeros. Now notice the numbers don't switch places just because the numerator's bigger. It still goes on the inside. So now we're going to ask ourselves, how many times can 2 go into 5? It goes in 2 times. 2 times 2 is 4. We subtract and we get 1. Okay, we're going to bring down the 0. And we also have to bring up our decimal. 2 goes into 10 5 times. 5 times 2 is 10. Okay, so we're done. So the answer to this problem is 2.5. So 5 halves is the same thing as 2.5. You can go ahead and pause the video here if you need to. Let's look at the next one. We have 7/4. So the 4 goes on the outside, the 7 goes on the inside. So we're going to add a decimal and 3 zeros. 4 goes into 7 one time. 4 times 1 is 4. 7 minus 4 is 3. I bring down a 0. 4 goes into, or I'm going to bring up my decimal here. Okay. You can always do that first if you would like. And the most important thing with all of this is that you keep your numbers lined up. If you don't keep your numbers lined up, then you could make many, many mistakes. All right, so 4 goes into 30 7 times. 7 times 4 is 28. Okay. We say 30 minus 28 is 2. Okay, we bring down the 0. 4 goes into 20 5 times. Okay? So 4 times 5 is 20. So we are done. So the answer to this problem is 1.75. And that makes sense because if you remember how to convert this to a mixed number, it would be 1 3/4. So 1 3/4, so if we have 3/4 out of a dollar, would be 175. So that makes sense. All right, what I'd like you to do is if you understand this, go ahead and pause the video, finish the rest of the problems. If you don't understand it, go ahead and follow along with me. All right, again, the denominator goes on the outside, numerator goes on the inside with a decimal and 3 zeros. 3 goes into 4 one time. 1 times 3 is 3. 4 minus 3 is 1. Bring down a 0. 3 goes into 10 3 times. 3 times 3 is 9. Okay, we subtract 10 minus 9 is 1. We bring down a 0. 3 goes into 10 3 times. Do you guys see a pattern again? So 3 times 3 is 9. 10 minus 9 is 1. We bring down a 0. 3 goes into 10 3 times. So notice we're repeating. So again here, we're going to use the repeating bar. So the answer is 1.3 repeating. And we're only going to put the repeating bar over the 3 because that's the only number that's repeating. The 1 is not repeating. Go ahead and pause the video here if you need to. All right, let's look at the next one. The next one, 5 goes on the outside, 11 goes on the inside with a decimal and 3 zeros. 5 goes into 11 2 times. 2 times 5 is 10. 11 minus 10 is 1. I bring up my decimal, bring down a 0. 5 goes into 10 2 times. 2 times 5 is 10. And I'm done because I have no remainder. So the answer to this problem is 2.2. Okay? And we're done. All right, the next one. The denominator goes on the outside. The numerator goes on the inside with a decimal and 3 zeros. 8 goes into 27 3 times. 3 times 8 is 24. 27 minus 24 is 3. I'm going to bring down a 0 and bring up my decimal. I'm going to extend this division bar. Okay, 8 goes into 30 3 times. 3 times 8 is 24. 6, bring down my 0, so 60. 8 goes into 60 7 times. 7 times 8 is 56. So 60 minus 56 is 4. Bring down my 0. 8 goes into 40 5 times. And 5 times 8 is 40. So I am done. So the answer to this problem is 3.375. Again, if I ask you to round this to the hundredths place, I look at the thousandths right here, and that's over 5. So I'm going to go ahead and round this up 1. So it would be 3.38. Right? Another thing you could see is it could say round to the tenths place. So if it's 3.375 and I ask you to round to the tenths place, we have to look at the hundredths. Again, this number is over 5, so the answer would be 3.4. So you could have 3 different answers depending on if the problem asks you to round. All right, and that is all that I have for you today. So if you have any questions, please jot those down in your notebooks, and we will talk about those tomorrow.